All right, welcome back, class. So this will be 8.1b, nth roots and rational exponents. So the I can statement, I can evaluate nth roots of real numbers using both radical notation and rational exponent notation. So this first example, this will be some review, root review. So 6 squared is not 6 times 2, it's 6 times 6, which is 36. In this case, with the quantity here, this is what would be -5 times a -5. So that would be 25, because negative times negative is positive. But now in this case, the quantity would be right there. So it's -1 times 9 squared. So that then would be -1 times 81, which is -81. So there is a difference between a form with the quantity around the negative integer or a negative and then the quantity around the integer. So what reverses squaring a number? That would be the square root. So in that first case, 6 squared is 36, so the square root of 36 would be 6. And then again, for the, what did I want to do here? The square root of 25, that then would be 5. If you introduce it as a squared value, then take the square root, then you could get a plus or minus 5, because -5 squared is 25 and 5 squared is 25. So what we have here are radicals, and the index is going to be on the root here. The radicand is going to be the inside, so the 8 would be the radicand, and then the radical symbol is this symbol. That's the radical symbol. So let's look at square roots in a little more detail. Square root of 25. So in this case, the square root of 25 is going to be 5. If, again, I'm reiterating, if it was introduced as like x squared equals 25, and then we took the square root, then x would be plus or minus 5. But in this case, it's the square root of 25, so that is 5. Now we have a negative inside, so we're taking the square root of -25. Well, there will be no real numbers, so this should be review where this will be 5i, because there's no value such that when we take the square root, it'll be negative. Because when you square either, like we did up here, when you square 5 or -5, you get a positive 25. So you can't take the square root of -25 and get a real number. So 90, square root of 90, this is review to unit 6 and 7 a little bit, taking out that factor tree. So we can break this down as 9 times 10. And then we can break 9 times 3 times 3, and then 10 times 2 times 5. Since the square root, there's an implied 2 as the index here, you need 2 factors. So when we simplify this, we get 3 radical 10. And you can also do it as radical 9 times radical 10, which is 3 times radical 10. 75, the square root of 75, we have the same case where we're going to look at that factor tree. Actually, in this case, I'm going to skip it just due to time. And then I'm going to skip this one as well. You're welcome to try these if you'd like. They'll be the same practice. So now, this case, we have the factors here for the square root of 20x squared times y squared. So 20 is, we could do 5 times 4, which we can break 4 into 2 times 2. So there's a factor. So 2. X is x times x, so there's 2x, and then y is y times, or y to the 5th is y times y times y times y times y. And we're looking for 2 factors because it's square root. So we have 2 and then another 2. So then it would be y times y out front, so that would be y squared, times what's left in the inside. So we have a 5 and a y left. So under the radical, we have 5y. So this would be the final product. Cubed roots. All right, so in the last case, we had square roots, and we were looking for factors of like 2. Now it's cubed roots, so we're going to be looking for factors of 3. So in this first case, we have 80. So we're going to want to break that down into, let's see the way I did it. So 8 times 10, and 8 is 2 times 4, which is 2 times 2, and then we have 2 times 5. Okay, so it looks like we have 3 factors of 2 here, so we can pull out a 2, and then we have a 2 and a 5, so those will remain. Oops, not equals. So we have 2 radical 10, because we could pull out 3 factors of 2. Next, we have cubed root of 81 p to the 5th times m cubed. So the first one, 81 is 9 times 9, which can be rewritten as 3 times 3 times 3 times 3. So we have 3 factors. Whoops. So we're going to pull out a 3. P can be, or p to the 5th is p times p times p times p. So we have 1, 2, 3. So 3 times p, and then m cubed would be m times m times m. So there's 3 more that we can pull out. So 3pm out front, and then what remains is what I haven't highlighted. So it looks like a 3 and a p squared is what's left under the radical. Oops, and it's cubed root. It's cubed root. Okay, in this case, it's cubed root of negative 125. So negative 125, the factors are going to be 5 and 25, and then 5 times 5. So we have 3 factors. And in this case, we can have a real number because it's cubic. So since it's cubic, it'll be that odd number, so you can get negative. So when we pull out that factor of 5, what's left is negative 5. And that's because negative 5 cubed is negative 125. Because when you have an odd amount of negatives that are being multiplied by each other, it will be a negative answer. So the cubed root of a negative will still be negative. So now on the flip side with this case, it's the cubed root of a positive, so that's 5 times 5 times 5. So when we pull out, because we can do 3 factors of 5, we get a positive 5 here. And that's a box, by the way. This is a box. All right, fourth roots. I'm assuming at this point you're guessing what it will be. If not, that's okay. But in this case, we're looking for 4 factors. So if it's like the fourth root of x fourth to the 4th, you would pull out 4 factors of x, all 4, and that would simplify to just x. So the fourth root of 64, that's 2 times 32, which is 2 times 16, which is 2 times 8, which is 2 times 4, which is 2 times 2. Okay, so we have 1, 2, 3, 4. So there's a factor of 2 that we can pull out times, and we don't have enough to pull out any more. So then it would be 2 times the fourth root of 4, because we have these 2 left, which would be 4. In this case, I'm going to do the integer first. So we have 8 times 10, which is 2 times 4. So that's 2 times 2, and that's 2 times 5. So we have 4 right there, so we could pull out a factor of 2. X to the 5th is x times x times x 5 here, so then we can pull out that one because it's 4 factors of x. And then for y, it's going to be 1, 2, 3, 4, 5, 6, 7, 8. So we have 4, so that's a factor of y, and then another 4. So that'd be y times y out front, so that'd be y squared. So what we have left under the fourth root is going to be a 5, and then we still have one x remaining. So this would be the final product here. All right, and this one, fourth root of 81, is going to be 9 times 9. So we can break that down to 3 times 3 times 3. So there's the 4 we want. So the fourth root of 81 is just going to be the 3. We have a negative. Now in this case, it's an even index, so we can't have like a negative up here where we had an odd index. So in this case, it is going to be imaginary because there won't be a negative number that when you take the square root, that'll be real. So we have 9 times 9, 3 times 3 times 3 times 3. So now it's going to be imaginary because of its negative, and it's an even here, so it's going to be 3i. So that'll be the difference between this one and this one. So maybe you can even make a note. An even index, even index, then a negative radicand equals imaginary. So in this case, we had that negative radicand and an even index, so it's going to be imaginary. So then for the rational exponents, we're going to be setting this up a little different. That's then of the form a to the x over n. So your index is this n here, so this n then goes in the denominator, and then your exponent, whoops, I wanted highlighter, to the x power is going to go in the numerator when you do the reverse. So for a case like this first one, just to give us an example, we would have 5 to the first power, and it's the cubed root of 5. So that 5 to the first is going to be put in the numerator, and then the cube, the index, is going to be put in the denominator. So the radicand exponent goes in the numerator. Also, now for this next one, there's an implied square 2 here if it's just a radical. That's kind of assumed because it's the square root. So then for this one, again, it'd be 7 to the first, so then it's 7 to the half here, because this 1 goes in the numerator and then the 2 goes in the denominator, so 7 to the half. In this one here, you're going to want to do what's inside first and then square it lastly. So we have, when we rewrite this, there's this 1. So then it'll be 2 to the third, and then we need to square it. Now it's like yesterday's lesson, where now it's power to a power. So we have 2 to the third times 2. So then that would be 2 to 2/3 power. So then that would be our final product. In this case over here, following through, would be 15. This goes in the numerator, and then this goes in the denominator. Some that you might want to memorize include a square, or the square root of a. So this would be a to the half, or the cubed root of a would be a to the third, because they all have that implied exponent of 1. And then this goes all the way down to then the nth root of a to the x. That's like that first example we did, was a to the x over n. But these first two you may want to memorize. All right, now we want to do it the reverse order. So we want to put it in the radical form. So we have 3 to the half. So then rewriting it, this was our index because it's in the denominator. So then it's the square root of 3 to the first, which a familiar form would just be the square root of 3. So the second case, it's going to be the cubed root because the denominator is 3, so cubed root of 5 squared. So because of that, you could rewrite it as the cubed root of 25, or you could take it this way. So you could do the cubed root of 5 and then taking it to the power of 2. So kind of looking at the power there. So there's a couple different ways that you can rewrite them. 6 to the 4th now, we're going to put the 4 in the index because it's in the denominator, and then it'd be 6 to the power of 1, which is just 6 here. And then I'm going to skip this one for time. You can try that one on your own. All right, now, from the practice we've had, we should be able to do these without a calculator. There won't be calculators on the exam, so we're going to want to be able to get that practice. This first one is the 4th root, and 625 is 25 squared, so we have 25 times, 25, so we can break that down to 5 times 5 times 5 times 5. So right there we have 4 factors of 5, so this is simplified to 5. In this next one, however, now there's a negative, and like that note we made, if we have that negative in the radicand, then it's going to be imaginary, so instead of 5, this will be 5i. Now for this one, the 4th root of 81 is going to be 9 times 9, which is 3 times 3 times 3 times 3. So there's the 4 that we want to pull out. So this is going to be just 3. Now in this one, we have the negative 81 to the 4th power. So this is our index. So it's the 4th root of negative 81. And this is to the 1st power, so that's why that 1 is gone. So now when we do the factor tree of 9 times 9, which is 3 times 3 times 3 times 3, it's going to be imaginary because we have that negative in here and it's an even index. So this is now going to be 3i. So for this case, we can rewrite this. So this will be our index. So the cubed root of negative 27. And take that all to the 2nd power. I'm going to do it the other way that I said you could do it for this instance here. So negative 27. So the factors are going to be 3 times 3 times 3. And because it's the cubed root, we're looking for 3 factors, so we have them. So now we have negative 3 squared. And when we square negative 3, that's going to become positive. So the final answer here is going to be 9. So now, on the different case here where we don't have the parentheses around, this would be rewritten as negative 1 to the 2/3 power times 27 to the 2/3 power. So our answer is going to be different. So let's start. Our index in this first one is cubed, well, for both of them, but this is going to be the cubed root of negative 1 squared. So the cubed root of negative 1, since it's cubic, we can have a negative. So it's going to be negative 1 squared. And then when we square that, we're going to get just 1 because negative 1 times negative 1 is 1. Now for 27 to the 2/3, again we have an index of 3. So cubed root of 27 squared. This is 3 factors of 3 here. So the cubed root of 27 is going to be 3, and we're squaring that. So then we have 1 times 3 squared, which is 9. So now we get 9. So in this case, it was the same, but there are cases where it could be different. I'm going to skip this one again for time. So this problem over here is going to be more interesting anyways. We have a negative integer and then now a negative power. So just like in yesterday's example, if it's a negative power, we're going to want to take the reciprocal. We're going to want to put it in the denominator. So negative 32, or actually we're going to rewrite this just to make it more clear. When we do the reciprocal, it'll be 1 over negative 32 to now 3 over 5. And I should make that more clear because it looks like it might be multiplying. So I'm going to go in small. So this is now to the 3/5 up there. And the negative doesn't get flipped because it's just the exponent that gets changed when we put it in the denominator when we take the reciprocal. So now we can do 1 over, it's going to be an index of 5, so it's going to be the 5th root of negative 32 to the 3rd power. So then we can simplify that, because negative 32 here is going to have 5 factors of 2, because 2 times 2 times 2 times 2 times 2 is 32. And since it's a odd index here and it's negative, it's going to stay negative. So then we have negative 2 cubed. And again, this is all in the denominator still. We have the 1 over. So when we simplify that, now negative 2 times negative 2 times negative 2 is going to be 1 over negative 8. So that's what that final product is going to be. All right, so now we have solving. I lost what page I'm on. Let me see. Example 9. We have solving the equations for real roots. And we want to isolate the power and take the appropriate root of both sides. Continue it with opposite operations if necessary. So we want to isolate the power. So in this case, it's x cubed. So we want to isolate x by itself. So to do the reverse, we're going to take the cubed root. So then what we're left with is x equals, well, the cubed root of 125 is going to be 3 factors of 5. So then we have 3 here, so x equals 5. I think this should look somewhat familiar. If not, again, that is okay if it's extra review. So we want to isolate, so we have to do opposite operations. So first we have multiplying, so we're going to divide both sides by 3. So then we have x to the 5th equals negative 1. And then we want to take the 5th root here. So then we have x equals, well, the 5th root of negative 1, it's a negative in here and an odd index, so that's going to remain as negative 1. And then now for this next one, similar, more steps added, but familiar. So we're going to want to add 3 to both sides, just doing the proper steps for solving for x. So we then have 2 times x plus 4 cubed equals, this would be negative 16. Next we would have to divide both sides by 2, so we have x plus 4 cubed equals negative 8. And we have to take the cubed root of negative 8. So then we have x plus 4 equals, well, here we would have 3 factors of 2. And it's negative and odd, so then we would keep that negative 2. So whoops, got ahead of myself. Subtract 4 from both sides, x equals negative 6. And in this last case, we're going to first add 7 to both sides. So we have x to the 4th equals 10,000. So then we have to take the 4th root. So x equals, well, 10,000 is 100 times 100, which is 10 times 10 times 10 times 10. Oops. I gotta write 10 there. So we have our 4 factors of 10. So in this case, x would just be 10 here. And actually, no, look at this. Since it's even and it's introduced as even here, when we take the square root, we're going to get plus or minus 10. And that's because when you plug in a plus or a minus 10 here, you will get that 10,000 out, because negative 10 to the 4th power is 10,000 and a positive 10 to the 4th power is 10,000. So x in this case would be plus or minus 10. All right, I think that's all we have for this one. So